Hello dear learners, welcome back to the second part of site analysis. I am architect Mansha Samreen from School of Architecture and Design, K.R. Mangalam University. In the previous lecture, we have talked about the physical aspects of site analysis. In this part, we will be talking about environmental and the man-made determinants of the site analysis. What is the difference between environmental and physical and man-made? So, physical determinants are the existing site condition in terms of the site boundary, site size, site geometry, site location. Environmental aspects mean what is the environmental conditions of that particular site pertaining to the solar condition, the thermal condition and the wind condition that exist on the site. These are the two predominant conditions that they environmentally impact any site. And the next aspect are the man-made determinants. Man-made determinants are the factors that are made by man. These are basically the developmental control norms which has to be taken care of while analyzing any site. So students, let's begin. So in residential context, the environmental and man-made factors basically run around the comfort, safety, feasibility and long-term performance of the housing. And we need to understand what are the constraints in the design so that the future planning influences can be taken care of, and the decisions that we are going to take for those planning aspects have to be initially started and taken into consideration. So, the physical factors impacting the site analysis are topography of the soil, the geographic condition, the climate that the site is present in, the solar orientation of that particular geography, the prevailing winds happening in that particular geographic location, the existing green cover and the water conditions. Water condition means what is the water table and what is the slope and the drainage of the site that you have in your hand. So, these factors determine the foundation systems of the drainage strategies and long-term building performance. And keeping all these aspects in mind, a good design can be made. The first aspect, which is the topography of the soil, basically means the elevation of the site. That means at what altitude the site is present. What is the slope of the site? What are the contours that are existing? These aspects will impact the overall drainage condition. That means when the rain falls, how the water is drained out of the soil, out of the site, because the site will have certain undulations. Any site is not plain. Depending upon the location of that particular site, the topography of that particular site area can be different. A site present in a plain region will be comparatively flat as compared to the site which is existing in a hilly region. It will have a lot of undulations. There would be peaks and there would be valleys that are existing in this in the site. And drainage of water is one of the important aspects that has to be taken care of while designing. So, while doing site analysis, the elevation, the slope, the contour and the way water moves out from the site is very important. Another important aspect is the geology of the site. Geology is basically history of the area, the bedrock type. It means what is the soil bearing capacity. The soil is very loose or the soil is very tough. What is the closest bedrock that is available. This helps to understand and design the foundation system, that what type of foundation system you are going to choose for your design. Is it a shallow foundation system? Is it a strip footing? Is it a strap footing? Or you need to go down deep till the bedrock to keep your building stable and go for pile foundation. So, the geology of the soil need to be tested before going for the design aspect and deciding what type of construction technique has to be implemented. So, it has a very big role while doing site analysis. Hydrology aspect pertains to the what is the level of underground water table, because on that the stability of the overall foundation also depends, because water makes the soil loose. So, where exactly the underground water table is present, it needs to be harnessed for the water requirement of the site also, plus it also impacts the overall stability of that site. Soil genesis evaluates what is the soil type, what is its erosion susceptibility, how much moisture it will absorb, what is the organic content of the site, and overall these factors work out and contribute to the soil bearing capacity, which is the major parameter, major aspect for deciding the construction process and the construction type of the site. Next important physical factors of the site analysis is the climate. So, under climate we evaluate the temperature, humidity, wind, rainfall conditions and solar radiation. So, climate data is never studied seasonally, it is always taken as annual averages. So, in temperature we work out what is the maximum and minimum day and night temperature versus dry and wet bulb temperature. What is the humidity, high, low or averages, the wind conditions, what is the wind direction, what is the wind velocity, the rainfall aspect, the precipitation, annual rain, what is the solar radiation, what is the solar intensity and orientation. So, all these factors club together and help you figure out the orientation and work out the fenestrations of your project. So, the first physical factor and the condition is the solar orientation. So, in solar orientation we need to understand first thing that the angle of the sun varies during the seasons, which is basically due to the tilting of the earth axis as it rotates around the sun. So, in the summer the altitude or the azimuth of the sun is on a higher azimuth, and during winters the sun is at a lower altitude. Because of these two aspects, the fenestrations are decided in any design project. So, in our residential design project, we need to take this factor as an advantage and design accordingly, because during summers we do not want harsh sun to enter our room, our building, our home. But during winters we all love the sun and we want that sun to come inside the house. So, how it is done? It is done by using this aspect of the azimuth and the altitude of the sun into the workable feature of our site analysis, and in turn work out the design solutions which make uses of this aspect. So, how it is done? It is done by properly orienting the building and making use of the space. In this solar orientation decision, trees also play a very important role. So, a very simple strategy can be done to put trees, deciduous trees which lose their leaves during the winter and have full foliage during the summer, to work it out. So, what will happen during the summers? The leaves of the trees will act as a barrier and it will not allow the harsh sun to enter into the building, and during winters the leaves will fall out and it will allow the sun to enter the building. Another design strategy can be making of overhangs, where the overhangs, when the sun is at a higher altitude during summers, the overhangs will stop the harsh sun to enter into the built environment, and during the winters when the altitude of the sun is at a lower level, then the sunlight can easily enter into the built environment. So, solar orientation also impacts the overall energy consumption of the built environment also, because sun does not come with sunlight alone. There is always a aspect of heat, which is a basic addition to the sunlight. So, sunlight is not just the light, it is always associated with the heat component also. So, as designers we need to understand how to handle this aspect. So, a building can put near the house and it can stop the sun from getting in. So, it is stopping the sunlight, it is also casting a shadow, and that shadow area will remain cool. So, many areas use this is the concept of self shading, which is used to reduce the thermal load of the building. So, the orientation decision, the orientation of the building in according to the solar orientation will impact the overall indoor thermal comfort, and as architects we need to do this smartly so that the maximum use of natural resources can be taken in. Solar orientation also has a lot of design implementations like discussed. In summer the shade or the openings will reduce the heat, and in winters the sunlight can be allowed to improve the overall thermal comfort of the building. Like you see on the screen right now, there are buildings which have overhangs. The overhangs will not allow the sun to come inside because of the projection, and yes, the sun is at a higher altitude. So, because of that these overhangs will cut off the direct sunlight to be entering, only the light part would be entertained and the thermal part would be cut off. Whereas during winters the altitude is on a lower level of the sun. So, the sunlight can directly access the fenestrations, the windows and the openings, and clearly help in improving the overall thermal comfort of the building. Many common mistakes happen that we just treat sunlight as a beneficial aspect and we ignore what is happening in the west, because if we see the movement of the sun from east to west, the maximum time the west facing facade is getting the maximum heat gain, and because of that the overall thermal mass of the thermal heat of the building will increase. So, orienting the building just for views is not climate, is not the design that you need to work on. You need to work on to understand how to orient the building strategically so that the sunlight is at a benefit for the overall design. Solar orientation determines comfort, energy use and spatial hierarchy in the residential design. Next important aspect of climatic factor is the wind direction. The wind direction majorly that is considered for any site analysis and design considerations are the prevailing wind conditions. Prevailing wind conditions are the winds that are the most dominant during the particular season. So, in India we see that we have seasonal winds, we have summer winds, we have winter winds and we have monsoon winds. So, the prevailing wind direction during these seasons have to be taken care of. What is the wind velocity along with the wind direction? These two are the two aspects which have to be taken care of together. So, in togetherness it is decided what is the wind direction, what is the wind velocity. A lot of data is already present and from there the architects take the predominant wind direction, wind velocity and the variations between summer, winter and the monsoon winds are taken into care of. So, how this is done into the design aspect, integration in design is very important. So, summer winds encourage airflow and cooling and ventilation, whereas winter winds block the thermal comfort. You feel uneasy because of the cold. So, when doing the design, this has to be taken care that how to orient the fenestration so that the basics of the wind, the underlying benefits from these winds are implemented into the building and not just it is used for airflow. So, obstructions which are in and around the site, like we just discussed in the context of surrounding. So, obstructions also impact the overall airflow and lead to wind blockage. So, trees can be reason for wind blockage, nearby buildings can be a reason for wind blockage, and due to that the area can be in no wind zone. So, wind deflections have to be taken care of while designing. Wind direction also helps to control the overall value of a particular house, a particular building, because wind direction is something which has to be taken care of. So, vegetation is present around, these will act as wind filters, not as blockers. Massing can be done to deflect and channelize the wind. A staggered blocks approach can be taken care of to avoid any wind tunnels and the venturi effect. We all know the venturi effect, where wind when travelled through small areas become more cooler. So, depending upon the requirement, either we want the wind to be cooled down, or we want the wind to be of a higher velocity. Depending upon this requirement, we can always work out where to orient our fenestrations and how to orient these fenestrations. Courtyards are another design strategies which help in releasing the pressure from the winds. As you can see in this sketch on the slide present, the trees are acting as wind filters, not as wind barriers. The fenestrations on the left side of the section are inviting the wind to travel throughout the house, and it is creating a ventilation effect, so that the overall house is being ventilated and fresh wind is circulated throughout the house. So, in wind direction, it needs to be controlled. We always allow controlled air to pass through the house and help in the ventilation. So, wind analysis will help architects decide where to open and where to protect and where to buffer. So, depending upon the prevailing wind conditions while doing the site analysis, it becomes easier for the architects to take the decision for the size of the fenestration, for the location of the fenestration, and for the exact size and opening. So, where to protect and where to buffer is something that helps the architects take this decision before actually designing the project. Another important factors, as we have been continuously discussing within physical factors, are the role of green covers. Like in the previous slide, just we saw how the trees are acting as wind protectors, and they are helping the wind to come inside the built environment. Another aspect the trees and the green covers have, that they provide shade and they reduce heat gain, and thereby they help in creating a microclimate which is not only just visually and aesthetically appeasing, but also works for the well-being of the people using the house. So, its effectiveness depends upon how the sun is oriented, what is the distance between the house and the tree that has been planted, what is the height of the tree, what is the spread of the tree, and what is the density of the tree. On these aspects, the exact role of the vegetation can be evaluated. For example, deciduous trees shade in the summer and admit sunlight in winter. So, if we are placing deciduous trees around the boundary along with the overhangs, it will help in letting the sunlight in and blocking the sunlight when not required. So, in summers it will block the sun and the heat, and during winters it will allow the heat and the thermal comfort of the indoor environment. Whereas evergreens are year round shade trees, and it reduces the glare that is coming inside the indoor environment. Glare means any discomfort that comes due to the harsh sunlight entering the house. So, during winters what happens? We have already discussed that the height of the sun is on the lower level. So, the sun rays will directly enter into the indoor environment, and due to this a glare like condition can be seen. So, to avoid that, year round evergreens can help in producing shade. So, best placed location for the trees and the green cover are the southeast and southwest for the low sun angles, and it can be combined with the overhangs present in south for the strong and the overall midday shading. The trees also help in defining space, and they also help in giving a view and a vista. It helps in providing visual screening and privacy, and it also helps in attenuating the airborne sound noise. So, if your site is very near a noisy road, planting of trees is a very good method to avoid the sound that is coming from the main road. Southeast and southwest protection is very much easily approved from the southeast present green covers. It can be placed along side boundaries along with curtailing down the noise. It also gives a privacy buffer as it acts as a visual breaker. So, planting trees around the boundary is a very good strategy. Near the openings, it will filter the daylight. Along the roads, it will stop the noise and it will stop the dust. Its placement matters more than the quantity. So, always work on the quantitative aspect, not on the work on the qualitative aspect and not just on the quantitative aspect. Next important factor is the sensory factor. Sensory factor, senses means what you feel, what you touch, what you hear, what you see. So, for sight conditions, the sensory factors are majorly noise and smell. Noise is generated from traffic, commercial activities, public spaces, and smell comes from the drains, waste areas, kitchens and industry. So, while doing site analysis, these two factors come under the sensory factors because it is not present or documented anywhere. It has to be evaluated by the architect and the designer when he goes on the site. So, on the site it has to be seen that where are the roads, abutting roads will lead to noise, the traffic will lead to the noise. The location, if the location of the site is near a commercial hub where a lot of activity is happening, a lot of public spaces are present, then again noise would be a factor which has to be catered either acoustically or by planting trees or by any other strategies. So, while designing, another important decision that designer has to make, the architect has to make, the how to take care of the noise if it exists on the site. Another is the smell aspect. So, if a drain is very nearby the site or a heap of garbage is near the site, the stench from these areas will impact the overall conditions of the site. So, it has to be taken care by the architect and the designer to handle these constraints in a proper manner. Another important aspect of man-made features that are impacting the site are the zoning ordinance, legal information, code, neighborhood context, historical values, utilities and services. The cultural factors basically describe the living condition and the context of the site. Regulatory controls define the permissible limit. So, we have already discussed zoning ordinance, legal information, codes in our lectures when we discussed the building bylaws. Neighborhood context was discussed in the previous lecture. Historical value and utilities are the important aspect which give the overall value to the site. It enhances the worth of the particular site. Next important aspect when we are doing site analysis is the SWOT analysis. SWOT by meaning means strength, weakness, opportunities and strength. So, all the factors that we have previously discussed in the two lectures today has to be worked under the hierarchy of the SWOT. So, each and every aspect has to be evaluated and the strength, the weakness, the opportunities and the threats that are involved in the project has to be considered while designing. There are some common symbols used in site analysis while doing the site analysis work. These are the common symbols that can be used for various purposes. These are the common drawing and color codes, like plot boundary lines have to be shown in dark line, existing street has to be shown in dark line, proposed can be shown in green dotted, permissible building line is shown in thick dotted, open space no color. So, all these are basics that has to be considered and taken care of while designing and drafting your site analysis projects. So, while going and presenting your site analysis, make sure you have your overview of the site, you have key photographs. Always mark north because it will straight away impact the orientation, sun path and wind direction. What are the relevant data that is available in terms of sun path and wind direction, important elements of the site and overlay of the drawings are important while you are presenting your site analysis. This is how a typical site analysis sheet looks like, which has all the important aspects and parameters of the site analysis. So, thank you students. Please do not forget to carry your measuring tape, checklist, notepad and camera when you are going for your next site visit. I will meet you in my next lecture, in which we will discuss on how site analysis impacts your design and concept. Thank you.